Okay, so the final part of projectiles are what's called the projectile motion formulae. Now, you don't need to remember what these formulae are, okay? You don't need to remember them off by heart. You do need to know how to derive them, because effectively the question will say either derive this formula or show this is a formula, find an expression for, something like that. So you need to be able to do that part. You don't need to remember them. And in fact, I would advise that you don't, because the formulae are quite hard. They have lots of unknowns. Getting them in the right order, actually solving problems using them, they are probably a lot harder than actually just solving the problems themselves. So there's only 2 examples that we'll go over for a lot of the formulae. It probably looks harder than it is because there are so many unknowns and you're not actually solving anything. So they're not very nice expressions, but has to be done, has to have a little bit of practice of it. So let's go with the 2 examples. So you have got a diagram, but again, you may not. A particle is projected from a point with on a horizontal plane with initial velocity u at an angle alpha above the horizontal. It moves freely under gravity until it hits the plane at point B. So you're not given it, but that's probably point A. Given that the acceleration due to gravity is g, find the expressions for the time of flight t and the range r on the horizontal plane. So the fact that it says due to gravity g, it means it wants you to use g in your expressions, not 9.8. You can't assume that g is gravity to 2 significant figures. The likelihood is it is. I don't know the questions on the exam well enough, because I haven't seen a practice question asking this yet, to know whether they'd accept you using 9.8 instead of g. I expect they probably would, but they are looking for you to use g rather than adding in another constant. Actually, quite often using variables is easier than using a constant, but yes, for now that's what we are going to be focusing on, and using g itself. So, part A, find the flight time of t. Well, the first thing we need to do, as always before we do any of these, is to find our initial horizontal and our initial vertical velocity. So UH, U cos alpha, and UV, U sine alpha. Okay, so the time of flight. So that is the whole time it takes to get here. We are going to resolve vertically because we don't have enough horizontal information. We don't know that distance. Acceleration is 0. We know the initial and final velocity are the same. And because we don't know time or distance, we don't have enough different information to resolve horizontally. So we're going to resolve vertically to find the time of the flight. So I know that the initial vertical velocity is u sine alpha. I know A is negative g because I have to find it upwards, otherwise this would need to be negative. I'm trying to find the time of the flight, which is capital T. Has to be capital T because obviously that's what's defined in the question. And I know that the displacement overall is 0. So S equals ut plus half at squared. So substituting in my values, O, 0, not O, 0 is ut sine alpha minus g over 2, because I think that's more straightforward than like half g multiplied by t squared. Now we want to find an expression for t, so obviously we're aiming to make t the subject of the formula, t equals. Now I've got t in two parts here, but I've also got a square. So I'm not going to be able to actually rearrange very easily to make t equals. In a case like this, my instinct should be to factorise it. And it means that you might have two expressions, but actually in this case it doesn't. So the only common factor to all of this is t. So t brackets u sine alpha subtract g over 2 times by t. So therefore, either t is equal to 0, which is great because that would be the initial time of the flight, or not t is equal to u sine alpha minus g over 2t is equal to 0. So either t itself is equal to 0 or all this is equal to 0, which is obviously when we get to this point, because our 0 is our displacement at the moment. Nothing to rearrange here, so this is not going to give me an expression for t, whereas rearranging this expression will. So we want to make t equals, so u sine alpha is going to be equal to g over 2t. Therefore, t will be equal to, I'm going to multiply by 2 u sine alpha over g, because I'd multiply by 2 and then I'd divide by g. So this is our expression for t. So it's not using anything that you don't really know. It's using your knowledge of rearranging equations with your knowledge of using SUVAT formula to solve for a problem like this. Okay, part B, which I do in different colours so it's easier to see, is finding the range of the horizontal plane. So even though it's in the diagram, let's say it wasn't, a reminder that the range is the horizontal displacement. So obviously we've got to resolve horizontally. So what I know is that the displacement oh god, sorry, I'm going to stop the video. My cat has brought in a mouse.